Welcome to Electronic Geek. In this video, we will see about voltage divider rule. We will see the derivation first and then we will try to analyze a few circuits. So let's get started. So what is a voltage divider circuit? A voltage divider circuit is a circuit which is formed of a one voltage source and a series combination of impedances. I'm saying impedances because this law is applicable not only for resistors but for inductors and capacitors as well. We know that the effective reactance offered by the inductor is XL, that is 2 pi FL. When you wish to apply the voltage divider rule to a network consisting of inductor and resistor, so what you do is you replace the inductance of the inductor with the effective reactance, okay, by 2 pi FL. And same goes for capacitor. You replace capacitor by its effective impedance, that is 1 upon 2 pi F. Therefore, a voltage divider circuit is nothing but a voltage source connected to a series network of impedances. We will see the circuit first, okay? So I'll take a voltage source, we'll place it. First, we are going to see resistive network only, and let's place these resistors in line 1 and 2. Right now, I am demonstrating with a 2 resistor network only. So, with wire tool, connect it like this. Now, we will supply 10 volts, and this resistor is of 500 ohms, and this is of 1 kilo. Now, if you want to find out the voltage at this node, or rather with respect to this ground terminal, okay, I'll put a ground over here. So suppose if I want to find out the voltage, okay, between these two nodes, this and this. So by our conventional method, what we do is we apply KVL in this loop, okay, and then after we get the net current, what we do is we multiply it with the resistance. So that is one way to do it. Using voltage divider, we have a direct formula. You can apply it and find out the value very fast. So first thing is we will do the derivation of voltage divider circuit, and then we will see how to approach when there are more resistors. So yeah. So if you see this circuit R1 and R2, a resistive network. So if you apply KVL, then what you will get is V1 minus IR1 minus IR2 equal to 0. Okay, keep V1 on this side, take this term to the other side, take I common, and what you will get is V1 equal to I times R1 plus I2, and you divide it V upon R1 plus R2. That's the effective current that is flowing in the loop, and voltage across this R2, that is we need our output over here, so that is equal to current into this resistance. So it is R2V upon R1 plus R2. So now if I ask to find out the voltage across this, rather than applying KVL, what you can do is simply 1000 into 10 upon 500 plus 1000. So if you do that, what you get is, let's say 1000 into 10 divided by 1500. 6.67 volts approx. So let's run this. I'll run for 1 second. So, see, 6.67 volts. To calculate this, hold the control key, click over here. 6.67. Now suppose if there are more than 2 resistors, okay, in a network, so I will modify this and let's place a third resistor. So this, let's give this third resistor a value of 2k, okay, 2 kilo ohms. Now my task is to find the voltage across this terminal and the ground. Okay, so now by using this same logic, okay, if you proceed, then your output will be R2 plus R3 times VCC divided by R1 plus R2 plus R3. Okay, I will repeat it once again. So if you have to find out the voltage across this point and this point, your output will be sum of those two resistors below, R2 plus R3 times VCC, that is 10 volts, divided by sum of all the resistances in the series network. So 500 plus 1000 plus 2000. So let's calculate the value first. So how much it turns. So the output voltage we saw it was R2 plus R3, which means 3000. Okay, 3000 divided by 3500, that is 0.857 into 10 volts, that is 8.57142. That is the voltage across this and this terminal. Let's see it. See how much we are seeing, 8.5714, which is the same as that of we expected. So similarly, if you have to find out the let's say voltage across this and this node, yeah, I will remove this for simplicity. So what you will do is it is simply R3 upon R1 plus R2 plus R3 times VCC, and you are done. Okay, so now let's solve a simple sum and we will see how this voltage divider rule is useful and it makes your calculations much easier and simpler. Suppose this is the circuit that you are having and you are given the task of finding the voltage across this resistor. Then what you will do is, you know that these two resistors are in parallel. 500 in parallel gives you effective of 250. Okay, so 250 ohms over here is the effective resistance and 1k. And if you find out the voltage across this, it is going to be 1k into 10 divided by 1250. Let's see that. So 1000 into 10, that is 10,000, divided by 1250, 8 volt. Let's see by running it. 8 volts. So you can see how handy and useful this technique is to analyze and design our circuits. So to summarize as to what we did in this video is, we saw about the voltage divider rule, we saw about the derivation, and we saw how to calculate the voltage at a particular node. So before ending, once again I will recall the formula. To calculate the voltage across this and this terminal, what you do, you sum up these two resistors down, okay, and you multiply it with the supply voltage and you divide by summation of all the resistors, okay, and that gives you the voltage across this terminal and the ground reference. So this is it for this video. Thank you for being till here. Thank you so much. Please do like, share and subscribe to my channel. If you have any doubts or suggestions, feel free to put them in the comment section. Thank you for being till here. Thank you so much.